For this project, I'm going to build a piece of chest armor that has an electronic combat data system and hit detection for LARPing. I'm using 10mm and 5mm EVA foam. I'm just going to roll out some 10mm EVA foam and just kind of freehand the shape based on my previous drawing. Now I'm going to roll out some 5mm EVA foam, but use the 10mm piece I already cut out as a guide. I want to make sure they are about the same shape, as they will be put together later. Now I loosely place the electronic components onto the 10mm cutout piece. I want to make sure everything will fit right. The antenna is 17mm. I want to make sure there's enough space. I'm going to outline the components area once I'm happy with their placement. I don't mark the piezo disc because it will be sandwiched between the 10mm and 5mm foam pieces later. For single components, if you press them into the foam, an imprint will be made, making it easy to mark their exact footprint. I like to cut a little extra space for the wires that come out the back of the charging harness. I'm going to cut a little more space for the buzzer and power switch, so they will be more inset. This will help prevent accidental power ons and offs, and to hide the buzzer and power switch better. See these little lines? Those are the terminals for the power switch. I'm going to cut these lines deeper so the switch and wires will fit better. I'm going to do the same thing for the buzzer. Now I'm going to use contact cement to attach the two pieces of EVA foam together. I like to use this silicone paintbrush because I can get a very satisfying peel when I clean the brush from contact cement. Before I apply contact cement, I'm going to test fit the two pieces to make sure everything aligns right. I like to mark the side each piece will have cement applied, so I don't make the mistake of gluing the wrong side, which can be an annoying mistake. While I let the cement dry, I'm going to solder wires onto the piezo disc. Make sure the wires are long enough to get to the Arduino. The contact cement on both the 10mm and 5mm pieces of EVA foam are dry enough that I can now press them together. Make sure to place the piezo disc between the two layers before pressing them together. I made the mistake earlier of not placing the piezo disc before pressing the two cemented sides together and had to go through a painful process of removing the 5mm piece of foam from the 10mm piece. So that's why the new 5mm piece I'm using now is slightly bigger than the last one. Awesome. Let's start the soldering. I'm going to start with the radio transmitter. First, I'm going to remove the pins soldered to the module's terminals. After I straighten out the pins, I'll use this razor blade to cut the plastic spacers so that the pins will fall out easier later. I am also going to attach this 10K ohm resistor to the positive of the piezo disc. This will help protect the Arduino, as the piezo can create high voltages when struck. I am connecting the resistor to Arduino's analog pin 1. I'm also going to prepare an additional 10K ohm resistor that will connect from that analog pin 1 to the Arduino's ground. I'll connect this later though, so it doesn't get in the way of the other pins while I'm soldering. Next will be the matching 433 MHz receiver. I'm pre-cutting the wires to the length I need to reach the Arduino. I'll pre-solder the wires, but attach the data wire to the Arduino's digital pin 11, leaving the positive and negative wires loose for now. I'll do the same for the 433 MHz transmitter, but I'll attach the transmitter's data wire to the Arduino's digital pin 12. This module is the HiLETGO 0.1 to 440 MHz high-speed RF power meter. You can get one on Amazon for about 12 bucks. I'm going to solder the wires to the data, power, and ground terminals. Then attach the module's data wire to the Arduino's analog pin 0. I'll also attach the module's power to the VIN pin on the Arduino. This RF power meter runs on about 7 to 15 volts, which is more than the Arduino can dish out, so the module will be getting its power straight from the battery. Don't forget to attach the module's ground to the Arduino's ground pin. Now I'm going to attach that last 10K resistor I prepared earlier to the Arduino's analog pin 1 and to the ground. I'm going to put some electrical tape between the resistor and Arduino board. This is because in my build, the two resistors I'm using are positionally stacked on top of one another. I wouldn't want an accidental short circuit since I am building armor and expect it to get knocked around a bit. I am also placing some tape on the RF receiver to protect it from the transmitter for similar reasons. And that's it for the main components. Let's move on to the battery pack. I am using three 3.7 volt lithium polymer batteries soldered in series to make an 11 volt battery pack. To wire the batteries in series, I will connect one battery's negative terminal to another battery's positive terminal. I will then connect that battery's negative terminal to the next battery's positive terminal. It's kind of like stringing them together like a train set. I like to use some electrical tape to bundle the batteries together. That way they won't move around too much. Let's see how the battery pack will fit into the armor piece. It seems to be a little snug, so I'm going to cut a little more space by slicing just the 10mm foam back. Be careful not to cut too deep into the 5mm foam. Now let's do the charging wire connector. Depending on the charger you are using, the wire colors might be off. Here is the wiring diagram for my charging setup. The red wire is universally the positive power lead. However, for my setup, it is the ground wire. Very scary. I like to cut a groove in the foam for the wires to hide in. As long as I don't cut too deep, I can stuff the wires in there and they won't get in the way or look weird when I place the phone backing. I'll use a small flathead screwdriver to sort of expand or chisel out the foam here. It's time to solder the charging wires to the battery pack. White to the battery pack positive terminal. Yellow to the middle battery cell's positive terminal. Black to the last cell's positive terminal. And lastly, the red wire to the battery pack's negative terminal. Let's see if everything fits. Yep, looks pretty nice. Okay, now let's talk chargers. This charger came from Amazon and it has a universal 4-pin connector on the charging side. It is powered via USB Type A. However, I find it works best if I use one of these older wall outlet adapters. This charger seems to be somewhat low power and doesn't really work with modern fast chargers. Now, I'm going to connect the piezo beeper and the power switch. First, I pre-measure the distance from the components to the Arduino. I'm running short on properly colored wire at the moment, so I hope no one minds the disorder. I'll connect the buzzer's white positive wire to the Arduino's digital pin 3, and the negative lead, the brown wire, to the Arduino's ground. Don't forget to take the sticker off the buzzer, or it'll be pretty quiet. I just realized I used the wrong wire for the buzzer, and it's not long enough. Now that I have the correct length of wire, I will pre-cut it for the Arduino's digital pin 3. I'm going to use the same trick as before and cut/chisel out a groove for the buzzer wires. I'll connect the buzzer's white positive wire to the Arduino's digital pin 3 and the negative lead, the brown wire, to the Arduino's ground. Now I'm going to connect the power switch between the Arduino and the battery pack. I also just realized I can merge the power switch lead to the Arduino with the groove I previously made for the buzzer wires. I like to cut the metal wings off the power switch to help it fit better in the foam. After stuffing everything in, I'll solder the wire from the power switch to the Arduino's VIN pin and the other end of the switch to the battery pack's positive terminal. Lastly, I'll connect a wire from the battery pack's negative terminal to the Arduino's ground pin. I will also cut a groove here to keep things tidy. I like to do a little power test before actually soldering the ground wire to the Arduino in case I made any mistakes. It looks like everything is fine, so I'll go ahead and solder it. One last check to inspect my work, and that's that. Now I'm going to connect the antenna. I'm going to connect another antenna to the transmitter's antenna terminal, and another antenna to the receiver's antenna terminal. I'll solder one of the antennas to the power meter's middle pin, connecting its coax cable connector to the board. I admit I'm not super familiar with RF technology, so I'm not sure if it's okay to run the transmitter, receiver, and RF power meter from the same antenna. So to play it safe, I'm just using 3 separate antennas. I'm going to now cut another groove for the 3 bundled antennas using the screwdriver to chisel out a small space. Next, I will secure the charging connector. I used to use Gorilla Glue for this as it bubbles and expands to fill up voids. But because I've had problems with the glue clogging at the connector terminals for the charger, I'm going to try UV resin. The idea is that it doesn't expand and dries quickly, so it won't have time to get into the connectors. And it looks good. Wow, UV resin for the win, guys. I'm going to use this 1mm EVA foam for the back cover. I'll just put contact cement in the general shape of the area I want to cover and cut it out later. I'm going to leave this area free so I can do more development on it later. I'll have easy access to the Arduino when I make new firmware. And that's it. A base combat data logging and hit detection LARP armor piece. As you can see, the inset of the buzzer and power switch and charging port are inset nicely as not to be easily seen but easily covered. Here's what this type of LARP armor looks like, fully skinned. And you can see the charging port and power switch here easily hidden underneath the leather. For this piece, I put the buzzer at the bottom to help with concealment. This is actually a flank armor piece. See the belt loops here? It is worn around your waist and rests on your hips. This is a shoulder pauldron I made. As you can see, I used a different style of leather to give it a different look. I put the charging port, Arduino access, and buzzer on the side facing the wearer's head to help with concealment. I seem to have forgotten where the power button is because I covered it with leather. This is an example of what I will do with a chest piece once I skin it. With this build system, your build options are basically endless. Happy adventuring!